Alright, so today we are going to start our unit on trig. So there are a few things you will need to know for the trig. The first thing being theta. Now theta, all it is it stands for an unknown angle. So just like x, we use for side length, so if we had any side, we could call it x. Let me fix that x. So it's just another variable, what we call theta, but we use theta for angles. So unknown angles will typically be called theta, which it's just that little circle with the line through it. It is a Greek letter, so this is where we start using the Greek alphabet. So theta is just a Greek letter, and it is used for unknown angles. The next bit that we will know, so for instance, if I had a right triangle, and I have this angle 30, I'd have theta, and say, alright, so what would be theta? So you could be able to figure out, so theta would be equal to 180 minus 30 minus 90, since that is a right angle, which is 90 degrees. So theta is just another variable, and it's used to denote angles. Alright, the next thing is the hypotenuse. I know you guys have gone over hypotenuses before. So the hypotenuse is merely what is directly across hypotenuse is just what's directly across from that right angle. So it is the side that is not touching the right angle. It's also going to be the longest side, which is why in the Pythagorean theorem, a squared plus b squared equals c squared. The c squared is always the hypotenuse because it's the longest. Alright, so it's always going to be the side opposite of the 90 degrees. The next thing you need to know is the opposite side, or the opposite leg, I guess would be a more apt name for it, since it is the side that is not touching the angle theta. So for any triangle we'd have some angle theta. So again, any angle, it could be this angle, it could be that angle, it doesn't matter which one, but it's always going to be the one opposite of it. So it's not going to be touching theta. So this would be the opposite leg. Again, it could be either one, so if theta was up here, it would again be the one opposite, so it would be the opposite leg. Probably learn how to spell, and I just erased my triangle. Alright, so the opposite leg is always going to be directly across, hang on, let me get yellow, across from the triangle theta. So it's always going to be across from the angle that we're using. So if it's this angle, this is going to be the opposite leg, but if we were using this angle right here as theta, then its opposite leg would be right here. So it's not a specific leg, it's not always going to be the short leg or the long leg. It's always going to be the leg that is opposite the angle you're using. So if you had a triangle with a short leg, if theta was up here, then this would be the opposite, which would be the short leg. Or if theta was down here, then it would be the long leg, that would be the opposite. So the opposite is always the one not touching the side, or not touching the theta. Alright? So it would be easiest just to show it with that. Now for the adjacent, again, this would be more apt to be called the adjacent leg. The adjacent leg is merely the side of the triangle. So if I had a triangle, that's not going away, and I had theta right here, the adjacent would be the one touching it. So this would be adjacent leg. Again, just like the opposite, it's going to change depending on where your theta is. Alright, so you're always going to want to highlight that theta or box it in. Not the theta, the opposite. So if theta was up here, the adjacent is going to be what was next to it. So it would be this leg right here. This would be the adjacent leg. So the opposite leg would be across, but the adjacent leg is always going to be touching, but it would be between the theta and the angle, the right angle, so the 90 degrees. So when you have the triangle, you'll always be told which one would be your right angle, and then you'll be given a theta of some sort. So to label it, what you'll be doing, you'll be highlighting your adjacent, so you know that this would be your adjacent. Actually, I'm not sure how well the white's looking up, so I'll switch to black. So adjacent leg. Your hypotenuse is always going to be directly across from your the hypotenuse will always be across from the 90 degrees, so you'll be able to draw the line straight from the 90 all the way across. So it will be the one side not touching it. So this will be the hypotenuse. And then your opposite leg will be the one, actually let's use a darker color, that's not touching that theta. So you know that this one would be your opposite leg. Alright. So again, you'd have your adjacent leg, which is the one that's going to be between the side that is between the theta and the 90 degrees. You have your hypotenuse, which is the one directly opposite the right angle or the 90 degrees, which is always going to be the longest side. And you have your opposite leg, which is always going to be opposite the theta. So it's going to be the one side that's not touching the theta. Alright? So in trig, we use these three sides and use measuring the angles. So we can use the sides to find out what the angles are, or we can use the angles to find out what the sides are. So one of the ways we can use this is by using the trigonometric ratios, which one of the ones is called the sine. So what the sine is you have a theta, so any point on the triangle. So you'll have the theta, which is going to be your angle. And it's always going to be the opposite. So again, the one that's on the opposite side over the hypotenuse. So it's always going to have whatever value is on the opposite leg over the hypotenuse. So for instance, if I gave you this triangle, let's say it was, I don't know, we have some theta here. We have this side, let's call it 5, and we have the, let's have it 5, and we have some hypotenuse, let's say 9. So we have our opposite side, which is 5, which is directly across from the theta, our hypotenuse, which is directly across from the 90 degrees. So for this, we'd say that the sine of theta, whichever theta we have, or whatever angle, sometimes we'll be given the angle, sometimes we won't, but it will be equal to the opposite, which in this case is 5, over the hypotenuse, which in this case is 9. So all the sine is the opposite side over the hypotenuse. So this could be used, so if you're given the angle and you only have one side on the triangle, well, typically for the right triangle we could use the Pythagorean theorem, a squared plus b squared equals c squared. a squared plus b squared equals c squared. Define any side so long as we had two sides. But if all we have is one side, the right angle and one other angle, then we could find that other missing side through this sign. So we can use sign to find a side so long as we have one side and the angles. Alright, so for your homework or for your assignment, not homework, this is what we do at the end of class. It is merely 4 questions in which you will be labeling these. So again, you'll be referring to that previous slide. So you'll be creating, you will have your triangle with your theta. So you'll be highlighting the, let's not highlight. So you will be highlighting your adjacent, which is between your theta and your right angle, and then you'll be labeling these. So you'd have your adjacent, which adjacent just means next to. So this would be like a house that's adjacent to yours would be your next door neighbor. You have your opposite, which is the side that's not touching the theta. And then you'd have the hypotenuse, which is the side that's not touching the right angle. It's also the longest side. Alright, so you'll be doing that for your assignment, and then make sure you tone it in by the end of class.